the first rule of Physics Fight Club is don't talk about the problems with Physics Fight Club. There is a self-evident crisis. I can show it to you numerically. Somehow, the idea is that a small number of people who are either at the top of the physics influencer pile, which is where I would put Sean, or at the top of the prestige pile in research, have held a view that is completely at odds with reality, whose key feature is the exclusion of different perspectives. So when, for example, I can tell, I probably can guess the AI, Pierce, from which you got the analysis of geometric unity. What you see is a very strange situation where a group of people go around attempting to throw shade on anyone who questions whether there's a massive problem in physics that everybody who's actually in the game can see with their own eyes.
Okay. Sean Carroll.
Well, I find it very telling. I don't know. It makes me sad that you are looking for a second opinion about geometric unity and you go to YouTube and see what pops up. I don't think that's the standard to which we would like to aspire. There are professional physicists right there in your country who work on understanding quantum gravity, field theory, geometry at a deep level, and you could ask them what they think. Look, there's a lot of talk so far about sociology, and I'd much rather talk about physics. But I would like to let people out there know who might be working outside the academic physics community that it is 100% possible to have a good idea and have it have an impact on what physicists do. But it's not easy. You have to do a certain amount of work to show that your theory is worth the time, that it is respectable, that it is interesting, that it is promising. The first thing you got to do is make sure that your theory makes contact with modern physics as it is understood. If you have a new paper out, physicists are going to look at it. They're going to look for, where's the Lagrangian? Where's the interactions? Is the proton stable? Is there dark matter? Like, how does it fit into what I already know?
Those are all different levels of the stack, Sean.
Eric's paper has none of that. You would also ask, has the theory been shown to be viable in a very basic way? Is it stable? Is it free of anomalies? Is it finite in the sense of the quantum mechanical calculation that I already mentioned? Again, none of that is there. Are there any new predictions? Eric says, and completely correctly, string theory doesn't make any new predictions either. But also, I really don't want people to get the idea that string theory has some dominant picture. In my department at Johns Hopkins, we have... Let me just finish and then you can talk. I think it's a good system. In my department at Johns Hopkins, we have 6 professors in the theoretical physics group. One of them does string theory.